Hello, welcome back. So we're done with most of quadratics. We're just left with a small portion of it, that is inequalities. So if you have something linear and you have an inequality, you can solve it, right? But now we will talk about inequalities, which will basically talk about quadratic inequalities. How do you solve these? So there's a cool little method for it, right? And let's just take one example. Let's say there's this quadratic, there's something like this, right? And I want to find the range of values of x for which, let's say, this quadratic is negative, right? Now this quadratic, let's say something like x squared minus 5x plus 6, and I want the values of x for which this is negative, right? So the very first thing that I will do in order to solve this is factorize this. So I can see that this can be factorized by middle term breaking. So x minus 2 minus 3 x minus 2, all the usual stuff we get are factors. Now here's the cool method. So first you make the number line, right? And then you look at the factors and you plot them over here. So x minus 3 x minus 2, basically we just factorize the quadratic, and so the factors will be x equals to 3 and x equals to 2, right? So you plot it on the number line, 2 over here, 3 over here, and what you do is you make a bar over here. Now you make a line, an arrow from left to right, starting from each bar. And as far as quadratic goes, if you want to find the values for which the quadratic is negative or less than 0, you look at the region with an odd number of lines or odd number of arrows, odd number of lines. So remember that 0 is even. So if we look at this portion, there are 0 arrows over here, so this is even. If I look over here, there is just 1 arrow, so it's odd. If I look over in this region that is greater than 3, it's even. So if I have to find the values for which it is negative, I will see the region where there are odd number of lines, and so my range will become 2 to 3, or a formal way to write it would be 2 is less than x is less than 3, right? Mind you, if this was an equal to sign, as in this was less than equal to, you will just put an equal to over here too, because this includes the equation being 0, which is when x is 3 and x is 2. Alright, so now let's say for the same quadratic, if we want the values for which this is positive, right? So for positive, we will look at even number of lines, the region which has an even number of lines, right? And so that region here in this case would be x being x being less than 2 and x being greater than 3, right? And if we look at our graph, this is 2, this is 3, it makes sense that this region is where it's negative, this region is where is positive, right? And I will talk to you about why this formula makes sense in a bit, but before, I want to give another example. Let's say I now have the quadratic x squared minus x squared plus 3x minus 2 is greater than 0. Alright, so the reason why I am doing this case is because over here my coefficient of x squared is negative, and so whenever the coefficient of x squared is negative, what you do is you first make it positive, right? You make it positive by, you can think of it by multiplying it by -1, or you can think of it as sending this stuff over there, right? So what we'll end up with would be x squared minus 3x plus 2 is less than 0. Notice how this switched. Now you do the usual stuff. Now it's the same as before. We factorize this x squared minus x minus 2x plus 2 is less than 0. X minus 1 minus 2, x minus 1 is less than 0. we got our factors 2 and 1. Now we make the number line. Here's 1, here's 2. We make our arrows. Now we want to find the values for which this thing is negative, even though we started with positive, but after rearranging we got to this. So we are looking for a region with odd number of lines, which is this, and so our answer will be 1 is less than x is less than 2. And if I make my quadratic, if I make this minus x squared plus 3x plus 2, it will look something like this, right? And so again, it makes sense that from 1 to 2 are the values for which it is positive, and then if you go to the left of 1 and to the right of 1, it's negative. All right, now why does this method make sense? When we factorize and then we make number line and the arrows, notice how before 1, okay, so let me write this over here, x minus 2, x minus 1. Right, so when x is less than 1, this is negative, this is also negative, and hence this is positive. Right, and when x is greater than 1, now we have one extra arrow, right? We drew an arrow starting from that factor, and so for x being greater than 1, we have this factor being positive, but this factor is still negative, and so we know positive multiplied by negative would be negative, and so this is negative. And if we look at x greater than 2, this will be positive. Now this will also be positive, as in both factors are not, the things that are multiplying are now positive, and so this will also be positive, right? And actually, by using the same logic, you can extend this to any other polynomial. Say if you have any cubic with roots 1, 2, 3, and you want to find the values for which that cubic is, let's say, positive, right? So we know that over here the three things that are multiplying, all of them are negative, and so this portion will also be negative. If you look at here, we know that one portion of this is positive, the other two are negative, and so this is the region where it is also positive, and you can continue on for these two, right? So if you have any inequality, if you have any polynomial, maybe there's an x cube or an x4, even though it's not in your syllabus, it's extra knowledge, and you have an inequality like this, you can always solve it using this method. Now one more thing that comes under it is, let's say I have this curve, and let's say I have this line, right? And of course it will intersect at some point, and I want to find the values of x for which this curve is beneath this line, right? So let's take some example. Let's say x squared minus 5x plus 6, the same example. This is our curve, our line, let's say x plus 1, and I want to find, let's say this is y1, this is y2, and I want to find the values for which y1 is less than y2. So x squared minus 5x plus 6 is less than x plus 1. X squared minus 6x plus 5 is less than 0. We can do x squared minus x minus 5x plus 5 is less than 0. X minus 1 minus 5, x minus 1 less than 0. We got our factors x minus 5, x minus 1 less than 0. Now we make the number line 1, 5, arrows, and we want to find the values for which this is negative, and so we want to find the region that is odd number of lines. So this region 1 to 5. So x is 1 to 5, right? This would be 1, this would be 5, this would be 1. I didn't exactly draw it perfectly, but you get the idea. Alright, so let's look at one last case where we have repeated roots. So let's say we have x squared minus 5x plus 25 being greater than 0. And so when we factorize this, we get x let's say minus 10x, right? So the factors we get would be x minus 5 whole square being greater than 0. So when you drop the number line, this would be factor 5. When you draw the number line, basically there are two repeated roots, that would be 5 and 5. So one bar here and another bar there that are at the same point, and we draw these two arrows. So what you will notice is that the whole region basically has even number of lines. Before 5 there are 0 arrows or lines, so it's even. After 5 there are 2 lines, so it's also even. And of course when it's exactly at 5, the y value is 0. And so if you want to find the values for which this equality holds, this equality will hold for basically every value except for 5, right? Because at 5 it is 0, after 5 it's even, before 5 it's even. So one way to write the answer would be x less than 5 and x greater than 5, right? Or you could say x is an element of all real values except for x is not equal to 5, or whatever. Just write this one, right? And that's all for inequalities.